Hello, my lovely psychology students. It's great to have you back again. Today's session, we are going to be focusing on, that's it, experimental methods. It's part of the research method unit. And here we have our spec link below. We're looking at the 4 different types of experiment, and that also includes the strengths and limitations of each. So let's get right into it. Let's start with laboratory experiments. It is important that you can describe what a laboratory experiment is, as well as some strengths and limitation. Key thing about a laboratory experiment, it meets the criteria of the scientific method or the scientific approach. And what we mean by that is that it is a highly controlled environment, because what we want to be able to establish is a causal relationship. Remember what we mean by a causal relationship. We want to see if we can establish cause and effect. Cause refers to the IV. How does that then affect the DV? And the only way we can do that is through bringing high levels of control. So it is really important that we understand control is of a key essence. Now, please note, a laboratory experiment can be any environment that can become highly controlled. So don't get the image of, scientists in white coats, lab coats, with all their chemicals and glass tubes and their flame Bunsen burners going off. No, our classroom, for example, can be turned into a laboratory because we've got that high level of control. And that high level of control can come about, one of the key ways is about ensuring the extraneous variables are controlled. Now, extraneous variables are all the other variables within the research, excluding the IV and the DV. So the researcher will identify what the IV is, they'll identify what the DV is, because the IV, remember, is the variables that the researcher is manipulating. The DV is the variable that is being measured to see whether the IV has any impact on it. And that means all the other variables within the research we classify as extraneous variables, and they need to be controlled. The reason why we need to control them is that we do not want them to have an impact on the DV alongside the IV. Because if they do, we would refer to them then as confounding variables. And that says, well, actually, there was something else, some other variable that actually affected the DV, not just the IV, and we don't want that to happen. So that's why we need that high level of control. Another way that we can bring in control is through standardization. The standardization is a way, again, to bring about control. We can have things like standardized instructions. And so standardized instructions can be given to participants. That means all participants get the same instructions in the exact same way. But that's not just for participants, because standardized instructions would have to be delivered by researchers, so that will be standardized on how they deliver those. We'd also have standardized procedures. That means we have these set format in which we carry out everything. And the nice thing about having standardization, it leads to replicability. Because remember, key features of science is the key ability to repeat the study. And remember, if we can repeat the study and get the same findings or similar findings, that means our data is becoming more reliable. But in order to repeat it, we need standardization in a collection of different ways so that we can be replicable. So highly controlled is really important in a laboratory experiment. So let's just look at some strengths and limitations. Strength, causality can be established. That means we can clearly see then the effects of the IV on the DV. And just like I said, we can also use as a strength, because of the high levels of control, we are going to be able to replicate the study in itself. Like everything, there's always a negative side. Now, if we have an environment that's completely controlled, it becomes artificial. And, you know, at the end of a piece of research, we generate findings. And what we want to do with those findings is to be able to generalize them to the wider population or the wider environment. And that causes a problem because it makes it more difficult to generalize it beyond the research situation, because the real world isn't highly controlled. It's not an artificial environment, so therefore it limits the generalization of the findings within the study itself. So it's really important that we understand that. Another issue that I suppose we could bring in here as a limitation is that there is going to be demand characteristics, because when participants are in a laboratory experiment, they know they're in a laboratory experiment. So that means they might alter or change their behavior because they think they perhaps need to act in a certain way, or they might consciously change their way they behave so that they come across in a better light. So we call that social desirability. That's a type of demand characteristics. We might also find that, oh, we're doing a piece of research, you know, are they trying to trick us? So the person might be looking for different cues from the researcher or the research environment, perhaps trying to guess things about what's going to come up next. So again, the researchers, participants are changing their behavior. And obviously an obvious one is that, you know, if they're asking, you know, to fill out a questionnaire, they might not be truthful. They might not give the truth. So demand characteristics is going to be a problem because that's got to do with the participants' behavior. Let's move on to field experiments. Now, field experiments, again, right? We're carrying out experiment where we've got an IV and a DV, but this time it takes place in a natural everyday environment. Please note, it's not literally in a field. Field just means that it's carried out in a person's everyday environment. So therefore, we're going to get more natural behavior of the participants. But you might think to yourself, well, yes, we know there's not going to be the same amount of control as a laboratory experiment. However, the researcher still identifies and manipulates the IV and still identifies and records the effect it has on the DV. So there's still researchers that still got a clear IV, a clear DV that they're focusing on. Now, with a field experiment, it is usually carried out covertly. A laboratory experiment, a participant knows they're taking part in a laboratory experiment. However, in a field experiment, they're usually carried out covertly. So the term we would use if in a laboratory experiment, so let's just rewind here a bit. Laboratory experiment, participants know they're taking part. Because you're going to a certain place, you're doing certain things that can be clearly controlled and clearly measured. So the term we would use there is overtly. Now think of overtly, if we get rid of the TLY, means over, on top. So if something's on top, it can be seen, so therefore we know. So if we talk about overt research, that means participants are completely aware that they're partaking in it. Whereas covertly, look at covert, get rid of the TLY, or sorry, not the TLY, the LY, we get covert. Get rid of the T as well now, we get cover. So it's undercover. So that means the participants are undercover. The experiment's kind of being hidden amongst everyday life. So they're completely unaware that they're partaking in that research. Now, the strength about this, because it's usually carried out covertly, participants, they're unaware that they're participating in a piece of research. So therefore, they're going to have natural behavior. Demand characteristics are going to be very limited. And also it's getting place in a natural environment in everyday life. So what does that mean for the results and the findings? It means, yes, we've got high levels of generalizability because it represents everyday life. which is a great thing for a field experiment. Now, it's also important that we know that actually we're going to have limitations again. Now, I'm going to talk about two limitations, one that's on the screen and another one that's not. A problem with a field experiment, we do not have a high level of control. So that means the extraneous variables are not controlled. And then if there's the lack of control on the extraneous variables, they can then become confounding variables. So they'll turn from extraneous variables and we will refer to them as confounding variables. And this means it's an uncontrolled extraneous variable that might have an impact on the DV alongside the IV, and that's going to skew our results. That's going to be a problem for our results because we cannot 100% say it was the effect of the IV on the DV when we don't have that level of control. Another is ethical issues. People are unaware that they're taking part in a piece of research. So actually, they might not want to do that. They might not want to be part of a research, but they're not given that choice. So we're not getting informed consent from the participants. And therefore, that's not good because people should know those type of things. We should know that we're partaking in a piece of research. And therefore, it's also going to impact on their privacy. It's going to have an impact on their privacy because they might not want people around them paying close attention to what they're doing. Now, we can move on to experiment number 3, natural experiments. And again, this is quite a different type of experiment. And this is where the researcher takes place of a natural pre-existing independent variable. Now, I put there the simple way to think of this is that it's something that's already happening. So let's understand that a little bit further. So it's about taking advantage of a pre-existing independent variable. And that's why it's called natural, because the variable would change naturally. So again, remember, an IV has usually 2 settings, without sugar, with sugar, right? So we might just be, watching something that naturally happens with or without. It would change on its own without any form of manipulation. So technically it would change even if the researcher wasn't looking at it. So natural means that the IV is going to change on its own without any form of manipulation. Now, please note, I also need you to note on this, is that the IV is natural, but not necessarily the setting. So that means we could have a naturally occurring IV and have 2 different settings on it, but we don't have to have it in a natural environment. So that means it could actually be tested in a laboratory experiment or even in a field experiment. No, I'm just giving you some, examples. For example, the effects of a TSAMI on mental health, right? Now, we don't know when it's happening, but we could have, got a history of what the person was like before with their mental health, and then what they were like after they experienced the tsunami in their mental health, right? I know I've got another quite extreme example here, but gunmen and shooting, and there's been some recently this year in America again, in the schools there, we can look at how children were interacting the day, before and how they would act after this event had happened. So it's something that would have happened even without the examiner being there in relation to a natural experiment. So that tells us there's no manipulation of the IV by the researcher. It's the IV is going to change on its own. And that's why it's called a natural experiment. The nice thing about a natural experiment, you could still carry it out as a laboratory, or you could still carry it out thereafter like a field experiment. Again, you know what's coming, strengths and limitations. It does have high levels of external validity because the IV is occurring naturally, so that means it's real behaviors. We are not creating any form of unnatural behavior. So therefore, that's a good thing because we're able to measure real everyday behavior. So that's a real strength of a natural experiment. And it also perhaps allows us to study behaviors or phenomena that don't occur very often. And therefore, we might find it difficult or find opportunities to study them. So when they arise, we can then take advantage of them. Limitations, right? Problem with that, on the other side, because they don't occur very often, we don't get the chance to bring things about, being able to repeat that study because it doesn't occur very often with regards to it. And also a limitation of a natural experiment is that it doesn't allow for random allocation between the conditions. We use that to limit bias from a researcher's point of view, but if we can't randomly allocate it, it could account for a level of bias coming into the research. So let's move on to our final, quasi. Now the word quasi means almost an experiment, but not quite. So when it comes to a quasi experiment, the IV is based on an existing difference between people. For example, our age. I'm 25, you're 16, 17, or 18. We can't change our age. I can't all of a sudden become 49, right? You can't all of a sudden become 6. So the IV is based on an existing difference between people. And there can be lots of them: age, gender, height, weight, right, ethnicity, you name it. These are things that we cannot change. That means there's no manipulation of the IV. Remember, a natural experiment, there's still a change in the IV when it comes to the IV, but that change is happening, that manipulation is happening naturally. Here, there's no manipulation whatsoever. And what really happens is the researcher simply exploits this naturally occurring difference between ages, between sex, males, females, masculine, feminine, height, 5 foot, 6 foot, 7 foot. These are pre-existing differences that the researcher takes advantage of. Here we have no random allocation of participants to the condition, as you would find in a laboratory experiment. If you're 16, you go into the 16-year-old group. If you're 18, you go into the 18-year-old group. You cannot randomly allocate to, because remember, in a laboratory experiment, we'll use random allocation to limit bias, especially researcher bias. So that means everybody has the same and equal opportunity to go into either condition. Well, in this quasi experiment, that doesn't happen. Okay, so that's a nice little overview of that. Let's just finish off with its strengths and limitations. Now, a strength of a quasi experiment, it can have high levels of control because we could carry it out like a laboratory experiment. If I have 2 conditions, because there's always 2 conditions of the IV, I might have the 16-year-olds in one condition and the 18-year-olds in another condition, and therefore we carry it out like a laboratory experiment. So that's a good thing, right? It can have high levels of control if we carry it out like a laboratory experiment. Limitation-wise, because there's the lack of random allocation, this can bring bias into the research. So this means that we're the researcher is using that pre-existing and you're going there, they're going there. So we're choosing by the researcher, and that could be a problem. Right, my lovelies, I know it's just a little overview, just to get your head around it. We're going to be doing some activities in class, but this can be used as a nice revision tool. Remember, if you have any questions, you know how to get hold of me, so please do. It's not about, oh, I'll do it tomorrow. Pop me an email, come in and see me, and then we can really develop your understanding. Take care, everybody.